Hello, everybody. I think we will start. It's time. Like Daniela said, I am also going to talk about Android things, and I'm going to dive a little bit deeper into the peripheral I/O library. Let's see if this works. Nope. So my name is Dennis Geurts. I come from the Netherlands. I'm co-founder and organizer of the Dutch Android user group. Also co-founder and organizer of the Things Network Arnhem. I don't know if anybody has heard of the Things Network. No? Yeah? Okay, thanks. By day I am a software architect at Luminis in the Netherlands, and by night I like to tinker with IoT. So that's me. So Android Things, it's a completely new form factor that supports Android next to the normal Android mobile phone, the Wear, TV, and Android Auto. And with that, you can do stuff that's not available in the other devices. And I would like to show you a little bit, give you a little bit more information about the platform. I'll skip over what Daniela said and go into the peripheral I/O. So like Daniela said, it's Android, so you can use the Android SDK. Android Studio is available. You've got access to the Play services, Firebase, Cloud platform. It's all there for you. And having said that, it really feels like you're developing an Android application. On top of that, for the distribution of your of the application, you have a secure developer console, and the automatic security updates are guaranteed by Google. So that's also very nice. So if some hardware vendor that uses Android Android Things decides to just abandon the project, Android or Google will still provide the security patches, so you're not left with an insecure device in your home. Danielle also mentioned the system on module architecture. They are really small. I mean, if I can point it, this is the SOM over here, and this is also a SOM. So that's the real chip that's doing the heavy work. The rest is all development board. So eventually you will have to create a development board, a hardware board yourself, and just you plug in the SOM, and then you're good to go. Install your app and ship it. There are quite some hardware platforms. Unfortunately, the Intel Edison was taken back, so they announced the end of life. So that's a real shame, because it was a very nice platform for this for Android Things. The Raspberry Pi 3 and the NXP Pico are the most used boards. They're mostly pin compatible. I say mostly because sometimes the I2C and the PWM ports, they are the same. The power ports are the same, but sometimes it's the GPIO is 1.8 volts, and otherwise it's 3.3 or 5 volts. So that those differences are there. So if you're an Android developer, and I think there are lots of Android developers, can I see some hands? Yes. Okay. Then you're familiar with this layer of services that are available for you as a developer. Android Things leaves away some of those because you're not gonna need it. You ain't gonna need it. There's no launcher, no content providers, no system UI, because also the displays are optional. So you have to really think. It's an IoT device, so you have to really rethink the interaction with your user. And well, most of the cases you won't need a display, so don't add it. So that said, Android Things, you have the power of Android also during development. It's all managed by Google, and its updates are automatic and secure. And I think that I can honestly say that Google has learned a lot about updates. So why not use that knowledge? So if you want to create an an Android Things application, like I said, you don't have this. You don't have keyboard. You don't have a display probably. So how do you interact with with the world? Well, we as people we use sensors or senses, and Android Things you use sensors, and there are that's why Android Things has a peripheral I/O library. So you can do GPIO, PWM, I2C, serial peripheral interface, UART, and I2S, so for sound, but I left it out over here. Based on those inputs, you can create user drivers, input drivers, sensors, GPS, and for some of them, the concept drivers are already created. So from going from left to right, you go to a higher programming language, or higher abstraction towards the for you to talk to the system. So digital I/O. Well, you have a pin, and this first is low. There's a voltage of 0 volts. That's a bit 0, and then you apply voltage, and it goes up. 5 volts, 3.3 volts, 1.8 volts, and then that denotes a 1. And that's how digital I/O works. And you can read those values and you can write those values. But first you have to have access to the pin. And like Daniela said, it works through the peripheral manager service. You open the GPIO and you set the direction. You either want to read or you want to write. And if you want to listen to changes, you can also set edge trigger types, edge falling. So then you wait for a signal going from 5 volts to 0, and then you get a callback. Looks really Androidy, right? And based on that callback, you can create, for instance, an input driver. You specify it on the top, and then you register that input driver. And based on the callback you can create a key event. So you've made more or less a keyboard with one key, spacebar. Okay, probably that's going to be used a lot. So in the driver library, Google already created this. So all the code that you saw in the last slide is now replaced by this. So whenever I say, hey, there's a driver for that, you can go to this link and find the driver. And mostly, almost always, no, always with example code, so it's almost plug and play. So that was GPIO. Well, let's continue to PWM, pulse width modulation. Where you can use it to control, for instance, a servo or a buzzer or dim light. And also, it is also used in low-level systems to be able to analog write a value. And you do that by setting the duty cycle and the period. And for instance, if your duty cycle is 0, then there's almost no voltage going out. And then as you increase the duty cycle, the duty cycle, you see that more and more voltage is applied to the outside. So again, the peripheral manager is used to open the PWM port, and don't forget to close it afterwards. And this is how you set the duty cycle and the frequency. So it's really easy. Probably, maybe somebody has heard that you can use PWM to control servos, which is quite hard to do. I mean, it takes a lot of stuff. It takes a lot of knowledge, but there's a drive for it, so it's already taken care of. So now you just have to say, okay, that's it. I know there's a servo on this PWM port, so let's create it, set the pulse durations, angles, and stuff, and enable it, and bam, you're good to go. So those are all low-level pin shifting stuff. We want some higher control, higher level control, and for that these four protocols are defined, and I will only cover these two. So to wire is a synchronous communication between one master and several slaves, and the master says every slave has an address, and so if a master wants to send a command to one of the slaves, it first sends the address, so then the slaves know, okay, it's not my address, I don't have to listen to this, and then and the one that has the address says, okay, now I have to listen. So in a real low-level view, these are the bits that are being shifted. I won't go into that. And the fun stuff about these devices is that you have lots of data sheets. You have to really dig deep into these data sheets, and then if you read it for the first time, you think, oh my god, how am I ever going to know how this works? But then you read it again, and you read it again, and then at some point everything clicks together, and you write your own driver. So this is getting boring. How to get access to the I2C bus? It's again through the peripheral manager. There's the bus, and then you can open a specific address, and you get over the bus, over this I2C bus, you get access to this specific device at this specific address. And you can open multiple devices over the same bus, and you can communicate with it. You can read the register, then write to it, or just read a register, or just send raw data to the device. Well, of course, there's also there's this chip. I have it somewhere over here. It's a very small chip. It's a pressure sensor, and it also has a temperature reading on it. And is this readable, more or less? This is the code that's extracted from the data sheet to get the calibration correctly for that device. So you don't want to do this. Fortunately, it has already been done. It's in the driver, so just do this, and you're good to go. And then read the temperature. So the next protocol, SPI, Serial Peripheral Interface. It's a bit different. There's a master, that's the same, and there are multiple slaves, but the slaves don't have an address. They have a chip select pin. So if a master wants to communicate with more slaves, multiple slaves, then it has to address the slave it wants to talk to by changing the chip select pin. Higher speed is possible. Let's not go into there. So this again is the low level bits that are being shifted. And again, lots of data sheets. You open the device like this, and then you have you can set frequency, bits per word, the bit justification. MSB, most significant bit first, is the default. Don't try to set the bit justification to true, because that doesn't work yet. So it's all beta. It's a dev preview. So once you have the device, you can send commands, and it's in a half duplex and full duplex. And yay, there's a driver for that. This is there's a LED strip that we have, and it's accessible over SPI. So maybe you should have used this one. Probably. Then you could have done it over using the Android Things platform only. So you have an array of colors and you write it to the device, and then the driver takes care of the communication. So I'm speaking fast because I want to do some demos. So I don't know if I have enough time yet. Yeah. So to sum things up, it's a real nice ecosystem that Android Things provides to you as a developer. The over-the-air updates with the added security is of course very nice. Don't know yet about what the costs are going to be, so I don't know what's the model Google uses for this, but we'll find that out. The ease of development is really nice, and hopefully there is already some sort of ecosystem for drivers, for peripherals, but I hope there will be you will be providing more drivers for because now you know how to do it. You're free to build your own. They really do accept contributions. So if you they do it, I think through the Google Plus Android Things channel. And I'm working on I like radio communication, so I'm working on these chips. The RFM95 is a LoRa gateway, LoRa chip. The NRF24L is a 2.4 gigahertz radio, and you have some low-level chips that work at 433 megahertz. So these are all in the open ISM bands. So you can you don't need a license to do this. Okay, I have some hardware lying down here. I will start with the PWM and then progress to I2C and SPI. I don't know if it's all visible, but let's try. So now I'm booting the NXP device. I have to wait till it boots. There it is. That was pretty fast, right? So I instructed it to do a slow blink, and hopefully at some point this LED will start blinking slowly. Hey, there you go. It's blinking. And this should be a fast blink. And right now there's no code being run by the Android system. It's a real command to the chip to start the PWM. So there's no power cycle, no cycles of CPU power used for this. And PWM, with PWM, you can also control a buzzer. Yeah, you get the picture. And if you combine all the other stuff, there's also this really nice rainbow head. You can it's a weather station, and you can control everything. That's doing some maintenance, because there's only one application that's allowed to, well, allowed, that's should run on the Android thing, and I just deinstalled the other one. So you have to reboot it. It's dev preview, right? So the permissions are being managed automatically, because you cannot have some pop-up with permission grant requests. So in the future it will happen automatically, but right now that you have to once reboot once the permissions change. But it's there already. Now it's there. The temperature is 28 degrees here. Well, on the chip. And if I press this, you can see the millibars, the pressure. And the LEDs are just a way of saying, okay, what's the pressure? So it's a complete weather station. Nice. So there's also that's my hobby, radio free communication. So I also have this Raspberry Pi, and on top of the Raspberry Pi I have this hat, and it contains the RFM95 chip, and I create a concept library for it. And hopefully it'll boot, and I have to connect to it, so that did take some time. So I have to create a ADB connection over the internet, but it's a local connection over here. But I have to know its IP address. Okay, that's taking too long, right? go to the next one. So with communication with the NXP it's much easier. So that goes to show how much more developed that platform is with respect to a Raspberry Pi. I think I never would use a Raspberry Pi in a production system, but it's great that they support it for the maker scene, so that you can really get a feel of how Android things works. And everybody's got a Raspberry Pi 3, right? Right? Can I show some hands? Okay. Let's see. Yeah. Okay. So I have this this other board. It's an XP board. It has a an antenna, two antennas. One is the Wi-Fi antenna, and the other one is the NRF chip that's it's able. Well, it's a radio that is able to listen and send data at 2.4 gigahertz. I've set the channel and stuff, and now if all is well, if I turn on this Arduino, there should be some output. Let's restart this one. So it did say that the system out E7, E7. Not yet. Yeah, radio communication is always funny. Ah, there you go. Did you see it? And I have another one. And hopefully the two Arduinos are going to talk to each other, and then the Android Things device will see their communication. Yeah. So one says hello Budapest, the other one responds with Devfest season rocks, and the Android Things device is picking up all the communication. So that's it. Questions? eBay, yeah, Alibaba, AliExpress, yeah. Yeah, I try to buy it one or two devices at a time. So I try to hide it between other expenses. Yeah. Okay, you're welcome. Yeah. Yeah. The NXP is right now the only one, only other available system. The NXP 7, the IMX 7D, that one. Yeah. Yeah. Okay. Thank you.